Hello and welcome to SudoKanard. We're here to solve this Japanese sums puzzle by Serbian author Zoran Tanasić. It was featured in WPF Puzzle Grand Prix, the first round of 2026. And this is not Sudoku, but I would argue that this is close enough to Sudoku. You still have to place digits into cells, and they still have to not repeat in any row or column. But the difference is that not every digit has to be placed. Not every cell has to receive a digit. And what you have in the margin is the sum of digits in consecutive cells containing digits. So for example, this 11, 11, 1 could have, say, 2 plus 4 plus 5 here. Then blank cells, then here we could have 8 and 3. Then more blank cells, and the cells will be denoted this way. So I will use shaded cells to denote the fact that they contain no digits, and green cells and shaded cells to mean that they must contain digits. And so we have here a run of cells containing digits which sum to 11. And same here, and a sum of digits summing to 1, which is necessarily a sole cell containing a 1. So this was a very expensive puzzle. It was worth 85 points, I think. I think this is correct. So, and I was glad I could solve it in a reasonable time. So let's start solving this. So there are multiple places to start. One of them is this. So this run of 4 nines doesn't seem that useful, but something you need to understand, something that you need to appreciate, is that every row contains 10 cells. And in those 10 cells, at least 3 of them will separate the runs of digits. So we're left with at most 7 cells to account for those sums. And only one run can be made of 1 digit, with the digit 9 being this one. And the other 3 will have to contain at least 2 digits, which means that we need at least 7 cells for those. And the same will be true for that, and the same will be true for that. Which means that on this row we have somewhere the 9 and 3 blocks of 2 digits, and then 3 lone shaded cells separating the blocks. And as a result of that, the shaded blocks must be in the middle, they can't be in the border. And the same is true here, and the same is true there. So there will be a single 7 somewhere, and 3 blocks of 2 digits summing to 7, which will be 1 plus 6, 2 plus 5, 3 plus 4. And likewise with 8, we will have the isolated 8 somewhere, and somewhere 1 plus 7, somewhere 2 plus 6, and somewhere 3 plus 5. So this is a first place to start. And I can see right now that this one will be here. So I can place the 1, and now I know that this 9 here will be 1 plus 8. We know that the blocks will be made of 2 digits exactly. And here we have a digit. The sum here must be 16, so we need at least 2 cells. And for 17, we also need at least 2 cells. This 2 here is made of only 1 cell, and it will be this cell here. So that's the 2. And then the 4 won't be 1 plus 3, so it will be a single cell. and it will have to be this one. And then we're left with 8, which could be an isolated 8, in which case, because of this, it won't be here. So if 8 is alone, it will be here, and if 8 is made with two cells, then it will be those two. So this cell will always be shaded. Okay, so that's for a start. This 8 here means that this can never be a 9. So this 9 here will be made of two cells. And this 11 here will be made of at least two cells. Same for this 12. By the way, this 9 now is fulfilled. And we know that the 9 will be either here or there. And that is definitely something. This 7 here will be 4 plus 3. That's interesting. Now, 16 is at most 5 cells. 1, 2, 3, 4, 6. So that 11, so that this belongs to the 11 group. I don't think I can do anything with that information, but I wanted to mention that. This looks promising because the sum of the two groups here is 43. And 43 is all 8 digits except for digit 2. So in the remaining 9 cells, we must place 8 digits and a block of separation, which means that the block of separation will be somewhere in the middle. And the first digits here sum to 18, and the first digits there sum to 25. 18 requires at least 3 cells. 25 requires at least 4 cells. So the shaded cell will be somewhere here. And we can see that on this row, this will be the block with only 1 digit, and we will have blocks with 2 digits here. And we can place the 7 into this cell, which is interesting because now this 7 appears to be this block. And 8 and the two 8 blocks are somewhere here. We could have a single 8 here, and actually the logic that I just applied here also applies on this row. This can only be one block, this 8, which means that this is 8. And this is only a block of 1 cell, and this 8 here requires 2 cells. We don't know which digits are in there yet. So now the remaining digits here, the remaining blocks of digits use 2 cells. And I could have placed this 6 for ages. So let's ponder what's happening here. Could 6 belong to the 17 block? If this is the case, here we have 14, then those are 1 and 2. And we still must place 2 blocks summing each to 13, but it would require this to be a 10, which is not possible. So 17 stops here. 13 takes at least this. We place digit 9 here. This 17 is done. And here we could have digit 7. And this is actually the only way to achieve this 13, because if I tried to join them, then those two digits would have to sum to 4, which would mean 1 and 3 is not available. So this is actually 7. And 3 must have digits summing to 10, which means at least 2 digits. And I don't think that 3 digits would work. We're left Actually, 145 would work. And all big digits are here, so that's the only possibility. Another way of seeing this is that the sum of all digits is 43, which means all digits but the 2. So here we have 1, 2, and 5. And that's interesting because the block summing to 6 here will be either 1 plus 5, or it could be 5 here plus 1, or it could be the sum of those two, or 2 and 4. This is not done yet. This column looks promising, so we have the block summing to 12 here. This is the block summing to 14, which means 5 plus 9 or 6 plus 8. And 18 requires at least 3 digits, so those 3 digits sum to 18. Here, this 15 uses this digit and at least 2 more. And we're left with this and that. So this 9 is a single digit here. And it is part of this 23, which means that those are 8 and 6, but the 6 is here. So that's the 6, that's the 8. This is one group of 2 digits summing to 8, and we have another group of 2 digits, which means that, which means that this here is not part of the block of digits. Eleven here uses at most 4 digits, so this is not part of 11, this is part of 16. We have a block with just digit 1 in this column, which means that 11 can't be 4 cells. 4 cells would be 1, 2, 3, and 5. So this 11 here is only made of those 2 digits. This 11 here will use at least those 2 digits, but not 4 of them here for the same reason. So that's the 1, and this is shaded. So that's the 1. It comes with a 6 here. This is 2 and 5. Where would be a next place to look? This 23 is fulfilled. This 15 here is now, does not use the 9, so it's 7 plus 8 here. This 8 shows that this is not 8, so this 8 takes 2 cells. And so this block here can only be with 5 here and 1 there, and that's a 3, to fulfill this 8 clue. And now this 6 is with 2 plus 4. Now what can we do with that? If this is a 2, then those 2 must sum to 16, which means 7 and 9. If this is 4, then those 2 digits must sum to 14, which will be with 8 and 6. All right. This 10 here requires 2 digits. And all 10s here require at least 2 digits, and we can't do anything more than that. This 5 here is there, so we have a block of 5 here and a block with the single digit 5. And this digit 5 is part of this 10 sum, so we have another 10 sum here, and a 10 sum with digit 5 can't be made of only 2 digits. So it will have to use 3 digits here. And now this block of 9 uses the 9 here. To go to 16, they must use 1, 2, and 4. That's the only way. And now because of that, this is a 5, this is a 2. And this 15 block now is here. So this is shaded, this is shaded. This 11, so we must add another 6. The only way is to add the digit 6. So those are shaded. This is a digit 6. This is 9, coming with 1 here. 8 uses 2 cells here. This 10 clue here, not using those digits, must be 7 plus 3. So 3 here, 7 there, which comes with the 1 for this 8 sum. This 8 here does not use the 4. It doesn't use the 2, so this is 1 plus 7. And we need a 5 to get to 15. And so this will have to be 5 plus 3. Yes, 3 is always that difficult to pronounce with me. For me, sorry about that. So no 1s in there. 4 here would require the 1 here, which is not available. So that's a 2, that's a 4, that's a 3, and that's a 7. And this 5 here is 1 plus 4. So that's really a smooth solving path. This 10 does not use 2 plus 3, so it will have to be 1 plus 4. This 9 now is 5 plus 4. And that's a 6 to complete this 11 sum. So this is now a 3 plus 8. This is 5. So let's ponder this. All this. This 8 is not 7 plus 1, and we already knew that. So what are the possibilities? We could have 5 plus 3 and then plus 6 to complete this 9. Or we could have 2 plus 6, which would be 6 plus 2 and 3 there. Oh, this 15, perhaps. Those two must sum to 9. 7 is not available, so this is not 2. This is 4. And that is 6 to fulfill this 10 clue. And now this 6 eliminates the 9 there. So to go to 18, the only possibility is with 7 and 2. This is 4, this is 8. Now this 14 is 8 plus 6. So 8 here, 6 there, which shades this cell. Here we need 25. We have 18, so this is 7. We are almost there. We still must achieve a sum of 12 here, a sum of 18 somewhere in here. But this 4 disambiguates that. 6, we need another 12, so that will be unshaded. Oopsie. Another 12 without using the 5, so 4 plus 8 or 3 plus 9. 4, 8 are not available, so 9 plus 3. Now this 12 could be 4, 3, 5, or 4, 6, 2. Oh, 6 and 2 are not available. So 4, 5 and 3, and 6 and 2. And this does not trigger. Why is that? Why is that? I must have made a mistake in my pen-pad interface. Where is my puzzle? I need to check with my puzzle sold on paper. I must find it, which is not an easy task. Well, anyway, I think this is correct. I'm not seeing any mistake. I'm just checking everything. Oh, there is a mistake in here, actually. That's a 4. Yes, that's a 4 to achieve this 13. So sorry if you were yelling after me for long minutes. So now this is correctly solved, and I wish I could find the motivation to show non-Sudoku puzzles more often on this channel. Of course, Japanese sum is a natural choice because this is close to Sudoku. But I also like loop puzzles, shading puzzles from time to time, to be honest. Anyway, thanks for watching this video. See you soon on SudoKanard.